All right, greetings. We are doing calculus today. And remember, this is ROP, results oriented preparation. And our motto is always early preparation equals excellent results. Okay, now what we're going to be doing today is we're going to be calculating derivatives from first principles. Okay, now there are many ways in which we can calculate these derivatives, but the first method that we're going to be using today is using first principles to calculate those particular derivatives. And basically, uh, we know that when we're calculating a derivative, what we are doing is we are differentiating. All right. So this is differentiation. All right. This is differentiation of whatever variables that were given in order to, we differentiate in order to get the derivative there. Okay, so there is a formula. The formula that we are going to be using in this case, the formula for calculating derivatives using first principles is the derivative of x is equals to a limit with h approaching 0, right? And then we have got f x plus h minus f of x everything over h. All right. Now, when we say limit with h approaching 0, our attempt there is to remove the impact of the h by making sure that our h there is removed as a result of it approaching 0 or as a result of it being the value of 0 there. All right. So this depicts the derivative of x, right? From the function of x, we can get the derivative of x. If we're using first principles, then our formula is limit with h approaching 0, f open brackets h plus x plus h close bracket, and then minus f of x. So whenever we're given a function using first principles, our first point is to first find this x plus h. F of x plus h is the first thing that we're going to be doing. All right. Now let us quickly look at an example. Let us look at our example. All right. In our example, we are told to determine the derivative of f of x. Now, f of x in our case is f of x is equals to minus 3x squared. All right? Minus 3x squared. So that is our function. So where we need to start then is to find fx plus h. This is where we start. All right? What it means is wherever there is x, we'll put x plus h. So we've got minus 3 and then open bracket x plus h squared. All right? Now we know that this one here, this one is the same as saying x plus h, x plus h. All right, x plus h times x plus h. Okay, so which gives us minus 3, open bracket, x times x is x squared. All right, x times h is xh plus another xh. This will give us plus 2xh. All right, and then plus h times h, which is h squared. All right, so x plus h squared is the same as x squared plus 2xh plus h squared. And then we multiply it by this -3. As you can see, -3 multiplies everything in that bracket. So we have -3 x squared plus this times that is going to give us a negative there, which is -6xh and -3h squared. So this is the value of x plus h. All right. Now that we've found the value of x plus h, what we need to do is then substitute it into our formula. All right. We need to substitute that into our formula: -3x squared minus 6xh minus 3h. Okay. So we know then that our fx plus h is equals to -3x squared minus 6xh and then -3h squared. All right, that is our x plus h. So now go into the formula now to find the derivative of x. The derivative of x, remember we're using first principles. We say that this one is going to be fx plus h minus a function of x divided by h. All right. Okay, I forgot something there. All right. That will be limit with h approaching 0, right? F x plus h close bracket minus f of x divided by h. All right. Always, it is easy to forget the limit with h approaching 0. So always remember to put it because we're using first principles. Then our next step is to substitute what we have into the formula there. This will give us limit with h approaching 0. And we know that our fx plus h is going to be minus 3x squared minus 6xh minus 3h squared. Sorry, yes, we're still continuing, it's not over. Minus, we have minus our function. Our function is a negative minus 3x squared, right? You see that? So negative and negative will give us positive 3x squared. All right. And then we divide everything by h. All right. Now let us solve that. Negative 3x squared plus 3x squared is 0. So that will leave us with a limit with h approaching 0. This one is out. We've got minus 6xh minus 3h squared divided by h. All right, that is what we have. And then our next step is we need to factorize. As you can see, h is common here and there and there. What we are trying to do there, we're attempting to get rid of the denominator in h. All right, so therefore we've got limit with h approaching 0, and we've got h open bracket negative 6x and negative 3h divided by h. All right, so that h and that h will cancel each other. H and h will cancel each other. And then you've got limit with h approaching 0. Now, where there is h, put 0, right? So this is 3 times 0 is what? 3 times 0 is 0. So our final answer here is going to be minus 6x. All right. So minus 6x is going to be our final answer. All right. We're going to look later in the next video on how to use a different formula instead of first principles to get that derivative. All right, we can even use the same example so that we see whether we can arrive at the same answer there. So in this case, this here, the derivative of minus 3x squared using first principles gets us to minus 6x. All right, so this is our example. Now let us go and look at a more challenging question, which is our question number one. Question number one. Question number one says, determine the derivative of let me just get the question. Okay, the question is of f of x is equals to 5x squared minus 4x plus 2. All right, now remember, we're determining this using first principles. We're using first principles, all right? Using first principles, not any other method for now, using first principles. Okay, so here, given that we know that the first place is to go to find fx plus h, all right? Now fx plus h, we say that it means that everywhere where you've got x, you put x plus h. So you've got 5 open bracket x plus h squared, all right, minus 4 x plus h plus 2. All right, okay, let us solve first. Remember what we said here. We said that this means that this is x plus h times x plus h. All right, so this will give us 5 open bracket x times x is x squared, again plus 2xh, right, plus h squared, all right, minus 4x minus 4h plus 2, all right, and then further this will give us fx plus h is going to be 5x squared plus 10xh plus 5h squared minus 4x minus 4h plus 2. Okay, so that is what we have there. Now, having found that, then we can go to we can now go to our formula. Substitute this into our formula, all right? Now, because of space there, let us just erase this and then we'll start with the formula on top. Remember that fx plus h is equals to 5x squared plus 10xh plus 5h squared minus 4x minus 4h plus 2. Remember that, okay? Because that's what we'll need, okay? Okay, now here we are, the formula. We said the derivative of x here using first principle is going to give us limit with h approaching 0, right, and then fx plus h minus f of x, divide everything by h. All right, okay, so this will give us a limit with h approaching 0. All right, remember what we said, we're starting with the f of x plus h, which we just found there as a value of 5x squared plus 10xh plus 5h squared minus 4x minus 4h plus 2. All right? And then we subtract the f of x minus f of x. We know there that our f of x was equals to 5x squared, right? Minus 4x plus 2. All right? So we take this one here. Okay? So for you to be sure, because this negative sign is going to affect everything there, so make sure that you put your bracket there, and then you've got 5x squared and minus 4x plus 2. All right? Now, the reason why you need to put the bracket there again is that this negative sign will affect everything there. All right? For example, coming down to limit with h approaching 0, sorry, I forgot h there, divide everything by h. Okay, divide everything by h. And then next we've got limit with h approaching 0. Okay, and then we've got, let us solve here, 5x squared minus 5x squared. So this is out. This one and that one is out. They separate each other out. And then we've got 4x minus 4x. So it's going to be 4x plus 4x. So that one is out as well. And then we've got, this one is out. This one is out. And then we've got 2. You've got 2 minus 2. All right. So the 2 and the 2 are out. So which means that we've actually gotten rid of all of the f of x there. All right, and then what is remaining now is we've got 10xh plus 5h squared minus 4h divided by h. All right, that is what is left. Okay, then we now factorize there. When you're factorizing, is limit with sorry, there's no division line there, with h approaching 0. All right, and then h is a common factor there. We've got 10x, all right, plus 5h minus 4 divided by h. Okay, we can tell that this h and that h will cancel each other out, and then what we have left is we've got a limit with h approaching 0 is equals to 10x, that 10x here, plus 5h, this one, minus 4. But we still have got limit with h approaching 0, which means we are getting rid of the impact of h there. Put a 0 where there is h. 0 times 5 is 0. So our derivative there is 10x minus 4. All right, so 10x minus 4 is the derivative of x. All right, that's the derivative of x. Okay, so remember, you have to be careful in this case because there are many variables that appear there. So it's easy to make a mistake in this step and forget one or not compute the right answer based on the signs that you have. Remember, this negative is going to change everything there. All right, so that is our first question. Let us go to question number 2. All right. Question number 2. Okay. Now in question number 2 again, we're still using first principles. The question says determine the derivative of our function now is f of x is equals to 2 divided by x. All right. Okay. Okay, first and foremost, as we said, we're going to find fx plus h. All right, which will give us 2 over x plus h. All right, that is what it gives us. 2 over h plus x. That is what we have. And then our next step is then to substitute this into our function. All right, let us substitute it into our function. All right. F, there is the derivative of x is f x plus h minus f of x divided by h. All right. Okay. Remember again, with limit with h approaching 0 is equals to the derivative of x. All right. Okay, please don't ever forget the limit. The limit with h approaching 0. Let us substitute. We found our f, this one here, to be 2 over x plus h, right? Minus 2 over x divided by h. This h. All right. If you want, if you feel it's better, you can put the divided sign this side. All right. H over 1. Okay. Okay. So I'm putting it in this way so that we can see that we are moving from there to there. Now we know that when we're dealing with fractions, we must have a common denominator, is it? All right. Okay. So come there. Limit h approaching 0. The common denominator for this is going to be x plus h and x, is it? H plus x and x. Or in other ways, to make it simple, we can say x and x plus h. Let me just create some space. H, x and x plus h. That is our common denominator there. Okay, so x plus h into x times x plus h, you'll have x. All right, so this will give us 2x. All right, was 2 times x. This and that will cancel. This one into that one will cancel, and then we'll have 2 times x plus h. So this will give us minus 2 minus 2x plus h. All right. Okay. All right. And then come down, everything divided by h. And then when you come down here, you are going to have minus 2x, this one, minus 2 minus 2x minus 2h. All right. Okay. Divided by x plus h. All right. Times 1 over h. Because we want to get rid of that. All right. Remember, this one was divided there. So when it comes, remember, we are dividing a fraction. All right. So this was h over 1. So now it becomes 1 over h. Okay. And then because of that, that will allow you to get rid of that particular h there. All right. The other h will go because this one and that, so this is 2, not negative. This and that will cancel each other, and then you have got only negative 2h, and then h times h out, so you only have got negative 2. All right, negative 2 limit with h approaching 0, negative 2 over x plus h. All right, here I forgot the limit again, sorry for that. Limit with h approaching 0. All right, okay. So what is our next step now, having come this far? All right, remember we still have got what? Limit with h approaching 0. We still have got only one h there, right? So where there is h, there is 0, so it becomes x times x, which is x squared. So now our answer is approximately negative 2x squared. All right, let me write it neatly there. Approximately, or you can just put an equal sign. This will give you negative 2 over x squared. Now the x squared comes from the fact that we've got x times x here, and then where there is h is 0 because we've got limits with h approaching 0. All right, now h approaching 0 becomes 0 there. X plus 0 is still x. X times x is x squared, so it's minus 2 over x squared. Okay, so that will be your derivative according to first principles on our question number 2. All right, now please always make sure that you remember to put the limit with h approaching 0 until the last end, where you actually apply the h approaching 0 by substituting 0 where there is h, and then you have our answer as minus 2 over x squared. And then on the other parts also, remember that when you come to this part where you are subtracting fractions, all right, you need to find a common denominator, and the common denominator is usually multiplying these times that. That is why we say x times x plus h, to show that this can go in and this can go in, and so they make a common denominator, as these become the factors of that particular common denominator by multiplying them to have x open bracket x plus h. Okay, I hope you enjoyed the lesson. Please send as many questions as possible. Otherwise, we will meet in the next video. Okay, bye.